Hey guys, Mr. Gardner here, and today we're going to talk about approximating square roots. So this is a strategy we use when we have to find the square root of a number that's not perfect. So to start out, we want to just talk about our perfect squares, and hopefully from last week you've started to commit these to memory, because really that's what you're going to have to do for the first 12 or so squares. You need to just memorize what they are. So we can see this table here is going to show us like when we square a number, what the value is when we come out. And then I've put the reverse version there as well. The square root of a number and what its square root is. So these are going to help us when we're doing our approximations in finding where the value sits in between. So that these are like our known values and it'll help us find our unknowns. Okay. So to look at this, to understand what we're going to do, we're going to start by looking at the square root of 10. Okay, so that's a really good one to start out with. So the first thing we want to think about is where the square root of 10 would be. So we can look at our tables first. And we would see that a number squared, so 3 is 9 and 4 is 16. And the square root of 9 is 3 and the square root of 16 is 4. And 10 is in between 9 and 16. So we know that 10 is going to sit somewhere in here between these two numbers, right? So the nice thing about that is that tells us that the square root of 10 is between the square root of 9 and the square root of 16. Well, the reason that's important is because we know what these values are. We know that the square root of 9 is 3. And we know that the square root of 16 is 4. So that means the square root of 10 must be between 3 and 4. We can see that here on our table, right? From both parts of our table. Okay, so then the next thing we can do is we can look at a number line. So then we know that the square root of 10 must be somewhere between these two numbers. Okay. Well, the next thing we want to do is we can label what these numbers are. And now we need to kind of look at it. So we can look at this table and we can find the middle. So the middle would be right about here, right in between. So that's going to be like 3.5. Okay, and then you want to think about what's in the middle of 9 and 16. So if I had 9 through 16, I've got 9, 10, 11, 12, 13, 14, 15, and 16. Then we can see the middle is going to be 1, 2, 3, 1, 2, 3, and then somewhere in between here. So it's probably like right in between these two. Okay. So the middle would be right there. About 12 and a half would be our middle number between those two numbers. Okay. So the reason this helps us, right, is now we're talking about this would be like the square root of 12.5 is going to be like 3.5. So that's going to be our middle. Okay, so now what we're doing is we're just getting our range a little bit smaller. So now we know square root of 9 is going to be less than the square root of 10, but the square root of 10 is going to be less than 12.5, the square root of 12.5. Okay, and so that tells us that now we're between 3 and 3.5. So now we can see that we're starting to get our approximation even smaller, right? Now we know that our square root is in between these two numbers, okay? So we can do this same kind of thing. We've got 9, 10, 11, 12, 13, but really we're talking about 12 and a half. So we can think about what the middle of that would be. And that would be, let's see, half, 1.5 would be about here. So 1.5 would be about here. So right about 11. Right, would be about our middle point, a little bit less than 11, so somewhere in there, okay? So again, we can see that that's bigger. So then we know that if that's in between the two, right, that's about 3.25, then we know that the square root of 10 is going to be between those two numbers. It's going to be even smaller, so it's going to be like between 3 and 3.25. All right, so that gives us an approximation right in there. Okay, and it's really close to this number, and it's really close to this number, so we could put it in there. So if we were approximating the square root of 10, we could say it's really close to something like 3.2. and that would be a good approximation. Okay. And if we actually do the math, it's not going to be perfect. Like I said, it's an approximation. Let's see, 3.2 times 3.2. And we're going to get a 4, 6. Remember, we have 2 decimal places. Put a 0 in. 3 times 2 is 6. Times 3 is 9. And if we look at this, we get 4, 2, 1, 10.24. Okay, so it's close. We're a little heavy. All right, we could do maybe like 3.18, but again, we're approximating. Okay, approximating. Which means we're just looking for close. All right, we want to be around the actual number. We're not trying to find the perfect number. If we're looking for the perfect answer, we would just use a calculator. Okay. So in this case, we're not looking for the perfect number. We're looking for just being close. So that's a really good at 3.2. If I was saying get as close to the tenths as possible, 3.2 would be a great approximation. All right. So let's just look at one more example. Okay. And just see, really get our strategy down for how we're going to be finding these values. All right. So let's look at a number like, let's do the square root of 2. Okay. Again, if we think about it up here, then it must be between 1 and 4, right? And we can see the square root of 1 is 1 and the square root of 4 is 2. So the square root of 2 must be in there somewhere. Okay, so that's really nice. We know it's in between those two. So again, we know that the square root of 2 is going to be less than the square root of 4, but it's bigger than the square root of 1. Okay, and if we look at the actual square roots, we have 1, some number we don't know yet, and 2. So that means the square root of 2 must be between 1 and 2. So it's going to be in between these two ranges. Okay, and we can just blow this up, kind of make this bigger so we can see it a little bit better. So let's say this is 1 and this is 2. Again, let's find that middle point. So that would be 1.5, right? Let's find that point really quick and see what about that would be. So what's in between 1 and 4? So 1, 2, 3, 4. All right, so if we had these numbers between 1 and 4, we're probably looking at something right about in here. So that would be like the square root of 2.5. Okay. And so that's really nice. Now we're looking, so we see the square root of 2, and we're between 1 and 2.5. So the square root of 2 is going to be in between those. So the square root of 2 is going to be somewhere in here. Now, is the square root of 2 going to be closer to the square root of 2.5 or closer to 1? Well, that's only a half away, and this is a full 1 away. So I'd say it's probably closer to up here. Okay, so again, we could put like our halfway point in, right? And this would be like 1.75. So then we know it's got to be in between here, about halfway in between here. So then we could say, right, if this is halfway, this is 1.25, then our square root of 2 must be between 1.25 and 1.5. All right, so we can just look at that. It's like right in the middle. So what would be right in the middle of those would be something like 1.35 or 1.3 or something like that. So it's close. Again, we're approximating, so you don't have to be perfect, but you want to get close. So we could say that the square root of 2 is going to be about 1.3. And if we wanted to go a little bit closer, we could do like 1.35. Okay. And check it. Again, we might not be perfect, but we're close. And we can just check how close we are by just doing the math. All right, we can just scratch it in really quick. 5 times 5 is 25. 5 times 3 is 15. Carry the 2 is 17. Bring the 1 up. 5 times 1 is 5 plus 1 is 6. Okay, bring down the 0. 3 times 5 is 15. Bring a 1 up here. 3 times 3 is 9 plus 1 is 10. Bring the 1 up here. 3 times 1 is 1 plus 1 is 4. Now we're going to bring in 2 zeros, and we're going to just do 5, 3, and 1. All right, we can just look. We got a 5, we got a 2, 7, 2, 1, 5, 8, 1, and we're bringing in 4 decimals. 1, 2, 3, 4. So really we're looking at 1.8225. So we're a little below square root of 2, but we're pretty close. So we could make it, you know, if we don't think that's great, we could say 1.4. Okay, so if we're approximating the square root of 2, we could say it's about 1.4. All right, approximately.